Hello, and in this video we're going to talk about computing the chi-square test by hand, specifically the chi-square test with one dimension. So, as we've talked about in previous videos, the chi-square test is a test to test the to see if there's a significant difference between frequencies of something occurring. So, frequently this is done in what's called a 2x2 table to test the difference between two proportions, but when you only have one dimension, it's also possible to do a chi-square test to see if there's a higher frequency of one category being chosen more than another. That's what the chi-square test is for. So it's usually done with 2 dimensions, but we're going to give the 1-dimensional example to show you how that's computed, and then that generalises pretty easily to 2 dimensions. So for the chi-square test, we look at data in terms of frequencies, and for this example, we're just gonna say we've got men and women in a study, and we want to find out if there's a significant difference in the frequencies of participants via the gender, or whether there's an equal split and a non-significant effect. So I haven't got a list of each participant's name and their gender. So in a way, I've already done the first step of the test. The first thing we need to do is count up the various numbers of the various frequencies, the amount of people in our various categories, and I've only got 2 here. But you can do the chi-square test with more than 2 categories as well. I've also added up the total, which is very important. So the premise of the chi-square test is that we're going to see if we have these frequencies that we observed in our study, but we can work out based on the number of cells or the number of possible options and our total sample size. If they were equally distributed between the 2 genders, then there'd be exactly half of our participants. So 70 would be male and 70 would be female. So the chi-square test looks at how far we are away from that, what the deviations are for each group, and puts that into a statistic and works out the significance of it. So how do we calculate that statistic? Well, the first thing we need to do is calculate our expected frequencies. And for a 2x2 table, or for a table like this where there are only 2 categories, obviously if there was no significant bias, we'd expect there to be 50-50. So we just do the expected count divided by the number of categories in this case. So we've got 140 participants and there are 2 categories, so we'd expect 70 to be in each. I've just added that in here, so 70 for both categories. What we now need to do is work out the difference, or the amount of error between that estimate and the amount we actually observed in our study. So because we have equal number of categories, it's actually going to be the opposite for each group. So if we look at the equation, all we're going to do is take our observed value, the value we saw in our study, minus our expected value. So for our first group it's going to be 16, and if we replace those expected values we get a difference of 16 in each group. One's minus 16 and one was plus 16. We've seen in lots of statistical calculations that minuses, positive and negative numbers, can be a problem because they cancel each other out. So to get rid of the minus problem, we often square the numbers, and that's what we do in this case. So once we've found the differences, we're going to find the square of those differences. So for the first group, we can see square of minus 16 is 256, and we also do that for the second group because it's the same number. we're gonna get the same value. We now need to have some way of working out that's the total variability, but or deviation from what we'd expect. But we need to work out some sense of average deviation. This is like dividing your total sum of squares, total measure of variability, and over divided by the degrees of freedom. It's basically saying we know this is all the difference in a study, but what would we expect it to be per participant? So all we're going to do is take those squared differences for each group, and instead of dividing by the sample size, we're going to divide by the expected frequency for that group. So we saw that both our values, both our cells had expected values of 70. So we're going to divide the square difference by 70, basically akin to creating an average, and we're going to do that for both groups. So we now have a mean square difference, and to calculate our chi-square statistic, all we do is add up that the amount that each cell deviates from what we'd expect, and that is going to be our statistic. So the chi-square statistic is basically the sum of mean square differences, and we get a measure that's essentially the average deviation from what would be expected in our study of 7.314. But we saw in lots of statistical procedures that in order to be able to look that value up, we need to work out something called degrees of freedom, and we saw in previous videos that degrees of freedom is the number of entities that are free to vary, hence degrees of freedom, minus the number of fixed entities or the number of entities that have to exist. So in this case, you can think of it like we've got two possible categories to choose from, but if a person doesn't choose one category, they have to be in the other categories. So they only really have one choice, because otherwise they're in the other one by default, because you can't have more than one gender. So in this, degrees of freedom for a chi-square statistic is the number of choices you have minus 1, essentially. So in our case it's 1, and if we look up that value in a chi-square table, we get a significance value of 0.006. That's less than 0.05. So we can reject our null hypothesis, essentially, that in terms of the chi-square statistic, that our observed frequencies are the same as our expected frequencies. So putting that in sort of research terms, we can say that the numbers of men and women we observed in our study were different than what we'd expect if they just were differed by chance. So there must be some systematic bias to one gender over another. Anyway, that was how to calculate the simple chi-square statistic. In future videos, we'll go on to look at 2x2 tables where we have proportions for two groups. So we want to see if the proportion of something differs between the groups. Anyway, thank you for watching this video, and I hope you enjoyed it. Bye bye.